Knights from Hoare Lea, and he's going to talk about a large-scale, very exciting project in the public commercial sector. Over to you, Tim.
Thank you very much. Yeah, so I'm Tim Knights from Hoare Lea, based in the Oxford office. And as Anna said, I'm going to talk today about a specific case study for Oxford City Council, the lessons that we learned from that case study, and how they can be applied to the vast majority of existing building stock. So yeah, the job itself, there's a couple of images there. I'll just give you a quick overview. Oxford City Council are committed to being net zero carbon operationally from 2030, which I think is common amongst a lot of local authorities. To try and tackle this challenge, they secured £11 million worth of public sector decarbonisation scheme funding. That was the original phase 1 funding back in 2020. The scheme itself was orientated primarily around heat pump integration and also some battery storage. And they focus on their 6 largest carbon emitting sites. That was an outdoor pool, Hinksey outdoor pool, 2 leisure centres, a community centre, an ice rink, and the town hall. The town hall subsequently disappeared. I'll come back to that. And there was a mixture of different types of heat pump, ranging from air source, ground source, and like I say, at Hinksey outdoor pool, there was a lake source heat pump. So we worked alongside Faithful & Gould basically to deliver MEP services and sustainability consultancy. When this job landed on my desk, the inquiry, it was quite evident that it was fraught with an awful lot of risk. Because it was Salix funded, the original Salix phase 1 funding was based on taking a very high level stage 1 concept all the way through the design stage to handover in 6 months. And that was across 6 sites, which was quite a daunting challenge. Especially given that any obviously major upgrades to fabric or anything that's going to visually impact on the site is likely to trigger a planning requirement that would delay the programme. And a number of the sites had ground source schemes. So again, ground source takes a lot more time to design and implement than an air source solution. The schemes, I think this is one of the key points, the schemes were based around 100% replacement of the gas-fired boilers. Now, some of these were leisure centres. They had boiler installations which are up to about 1.4 megawatts of boiler power. So that, in air source terms, is a sizable piece of kit. There was obviously a desire to minimise operational shutdown. We'd just come out of lockdown. The last thing that the City Council wanted to do was close the leisure centres, because you could imagine they'd be all over the front of the Oxford Mail in that scenario. Because it was Salix funded, there were CapEx requirements. Back on phase 1, it was 500 £500 per tonne saved over the lifetime of the project. And because there were existing buildings, we needed to interface with the existing plant and infrastructure without knowing its condition. And obviously, because they were generally aged installations, they all operated at much higher temperatures than heat pumps can deliver. So it quickly became apparent that we were going to have to work within the constraints if we stood any chance of trying to deliver this scheme. The key constraints being the programme, which I've touched on, operational disruption, CapEx limitations, plant space, planning and governance, electrical supply, and acoustics. And I'm going to come back to those and go through them all in a bit more detail. So these were the measures that we implemented to basically stand a chance of delivering the scheme. We changed the schemes. I think there was 2 schemes that had ground source heat pumps. We changed them to air source. We simply did not have the time to get ground source installations in, and they were heating led schemes. Actually, there's hardly any cooling on these sites. So the actual efficiency between air source and ground source wasn't particularly different. I think this is the key point. Heat pumps were introduced in a lead heat source capacity. So we basically sized them within the constraints, whatever the constraints were, whether that was available power on site, whether that was available plant space on site. By taking that approach, we were able to restrict the works purely to external areas and plant rooms so we could keep the facilities operational. We got around the planning challenge on most of the sites by working within our the general permitted development rights. So by keeping any external plant enclosures that were introduced to a volume of 200 meters cubed, we avoided a requirement to trigger a planning process, which again, we just simply did not have time to do. These schemes were design and build route adopted. We brought a contractor on really early doors. We got them through the door at the start of stage 2 when we came on board through the Southern Construction Framework under PCSA. That was incredibly beneficial because they were able to go in and do some real intrusive testing and validation and condition surveys of the equipment that was there, so we knew exactly what we were dealing with. There were quite collaborative approaches adopted. So we were client side, delivering a set of employees' requirements, performance specifications, design intent drawings. The contractor team were doing the final design. We didn't have time to go through a traditional process where we issue a set of employees' requirements, they take them, digest them, go away, bring on a design team, do the design, send it back to us to check. Simply didn't have the time. So we worked in tandem from the outset. We basically concentrated on our areas of strengths. We did the schematics, they did the external site plans, they did the plant room layouts, we did the calculations, and we basically exchanged files on a date in time and basically delivered stage 3 ERs and the stage 4 contractors' proposals on the same day. We had to procure the air source heat pumps very early doors. Again, because of the meteoric application of heat pumps to solve the carbon crisis, they're on very long lead times, up to 30 weeks at the moment, from placement of order. So we did that on some stage 2 information. And we had to, unfortunately, reduce the schemes from 6 to 4. We just couldn't get all 6 done within the money, within the time. The town hall was substituted for another leisure centre. And the town hall is something that we're subsequently looking at now. And crucially, we got a programme extension. I think Salix realised on phase 1 that 6 months was just unachievable. So now all future Salix PSDS funding is on a 12-month programme. So the graph on the screen there just gives you an indication of the size of the heat pumps that we installed compared to the size of the existing heating installation. So you can see they range from 12% up to 37% on Hinksey. Hinksey was slightly different because it was a lake source installation. So quite small installations. We maximised the way that we maximised the impact that they had on carbon emissions by some fairly innovative techniques. Because they were leisure centres primarily, most of the load was associated with the pool hall itself in terms of the air load, the heat and space, and the water load. So for the air load, in all of the air handling plant, because they're fully mechanically ventilated, we basically replaced or put additional cores in to get the same amount of duty as we could get with the higher temperatures that you get from gas fired. We introduced lead plate heat exchangers onto the pool water plate heat exchangers so that they could do as much work as they could before the boilers did the rest. To do that, we put some diverter valves in on the return circuits. So whether that was the ventilation circuit, the pool water plate heat exchanger circuit, or the space temperature heating circuit. And what we did is we basically diverted the return circuits through the air source installation so that could do as much work as it could to get it to the temperature, as high a temperature as it can within its operating parameters, typically about 45 degrees to get it to work efficiently. And then where necessary, we just injected heat in from the boiler circuits through an injection valve or flow circuits. By taking that approach, it meant that our existing gas-fired boiler installations would only really operate at very low temperatures, or when there were significant heating system demands, or when we needed to inject heat into the existing high temperature circuit. So the ventilation circuits pretty much all went to air source because we could just put coils in at 40, sized on 45 degree flow temperature. The plates we put on a really big delta T so that the air source could do a huge amount of work before the boilers kicked in. And for the space heating circuits, basically, they don't need to operate at 80 degrees. They're compensated circuits based on the outdoor temperature. So whenever the calculated compensated flow temperature was below 45 degrees, we just diverted it through the air source installation. The beauty, I think, of existing buildings is hopefully you can get a load of data. We had half-hourly meter data for every single installation for gas and electricity. So we knew exactly how those buildings performed. So we took that data and through analysis of the gas data, we could work out what obviously the heating load was for every half-hour period. And then by mapping in a weather file, again, half-hourly weather data given the external temperature, we could work out exactly what the performance of the air source heat pump system would be, because we had part load data based on external temperature and flow temperature. So when you sum all of that up, you can get a really accurate understanding of the difference that it's going to make to the gas and electrical footprint, and obviously the carbon footprint. So that gives us really good confidence in the figures that we were predicting. And because we had the electrical data half-hourly, we could map in our, the orange yellow line is the before, the electrical consumption, and the red line is the after the heat pump installation. And the grey line at the top is the agreed peak maximum capacity that the site in question had. So we could prove that we weren't going to trigger the requirement for an electrical supply upgrade. I'll come back onto that in a minute. So we were expecting this top section, some pretty significant changes, ranging from about 75% up to about 99% reduction in gas consumption. And electrically, again, with the leisure centres, there's an array of values there, but overall about 53% increase on average. These two tables represent what that translates to in terms of carbon emissions. The middle table is based on the BEIS 2021 greenhouse gas conversion factors, which are slightly more conservative than the new factors, the SAP 10.2, which are the basis of the current Part L assessment. But you can see, based on BEIS, it was 56% reduction on site carbon emissions. That's not just the heating system. And it's up to 66% if you take the SAP 10.2 figures. That was equivalent to about 963 tonnes on the conservative value, which doesn't mean a lot to many people. So we put some comparables up there. What does it mean? About 5 million miles in a family car, or 5 million kilometres in a passenger jet, 45,000 trees. This is the most worrying statistic for me, 97,000 Big Macs. It's a worryingly low number. But yeah, so you can see predicted to make a real difference. And the great thing with heat pumps is because the grid is continuing to decarbonise, the sites will continue to decarbonise. So the sites have been up and running for somewhere between 4 and 7 months, so about 6 months on average. So the grey bars represent what we predicted, and the green bars of where we actually are. So there's obviously a shortfall against the predictions. Only 3 of the sites are actually currently operational because the outdoor pool is not open. That doesn't open until April through to September. And we've obviously gone through the coldest part of the year, so that's when the heat pumps are going to have the least contribution. So that's one of the reasons why. And we've had a few teething issues in terms of plant failures, etc., along the way. But even though those numbers are down on where we predicted, that still equates to 1,571 megawatt hours of gas reduction across 3 sites, 248 tonnes of carbon reduction. And the interesting statistic as well for the client is we've actually saved them £100,000 in OPEX. So from that scheme, that Oxford City Council then invited us to write the brief. They asked us to produce a heat decarbonisation plan for them, for the town hall, a building opposite, which is a 1920s office building, and a 1980s neighbourhood community centre. So we basically approached the heat decarbonisation plan in line with all the guidance in terms of the hierarchy for decarbonisation. Guidance from this actual commission was funded by Salix again through the Low Carbon Skills Fund. So they give a guide on how to produce heat decarbonisation plans. But what we did is, whilst we did the hypothetical assessment of the difference that a fabric first all electric solution would make, we also put in an alternative approach where we said that if you take into account the constraints of the site and put a small heat pump installation in, it will have this much difference. So off the back of that, we saw numerous inquiries, commissions, had lots of conversations. Same challenges came up time and time again with existing building stock. Program, operational, disruption, plant space, money, planning, governance, power, and noise. Now, unlike new builds or major refurb projects, which have a dedicated budget, which you can organically carbonise from, you can make choices to adopt low carbon solutions. The money's there. Dedicated decarbonisation focused projects require dedicated funding. And I think this is a real challenge, particularly for the public sector. That's why there's so much interest in the Salix funding schemes. They simply do not have the budgets to decarbonise. So when they do secure funding, you need to stick to it, basically, that they have nothing else to contribute. Operational disruption, I think, this is a real challenge for existing buildings. To go to a major fabric upgrade, like externally cladding the walls, or an all electric heat pump solution where you will have to change all of the heat emitters because they've been sized on higher temperatures, and potentially the pipe work, which will shut the building. The jobs that we did, because of the way that we teed them in, and it was plant areas only, we kept those buildings fully operational. There was no downtime. Plant space, if you go back to the town hall that I flashed up a minute ago, it's a grade 2 star listed building in the centre of Oxford, and it has no external land at all and lots of ornate pitch roofs. The ability to drop in a 1 megawatt heat pump installation just does not exist, and it's grade 2 star listed as well. So plant space constraints can be a real issue. Again, on roofs where you've got a bit sizable heat pump installations where you've got plant on existing roofs, structurally it might just not stack up without major works. This is a real issue because of the extensive rollout of heat pumps and electrical vehicle charging infrastructure. The grid is under real pressure, particularly in Oxford. I'm going to just touch on that at the end, but by working within the available power constraint, we avoided on 3 of the 4 sites having to do any kind of electrical supply upgrade works. Planning, we talked about, it takes time, time that might not be available depending on your funding source or your delivery program. And acoustics are noisy. Air source heat pumps are noisy. And on the sites where in question that we looked at, they backed onto quite extensive residential premises. So acoustic mitigation measures for heat pumps result in big bits of kit, which again can trigger a planning requirement. So a much smaller installation helps to mitigate against that risk. So on there's the heat decarbonisation plan that I mentioned for Oxford City Council. That's the size of the plant. There's there, megawatt, 650, 200 kilowatt boiler installations. We put fairly small heat pump installations. Well, the assessment is based on fairly small. And if we did nothing at all, just feed them into the plant, into the plant rooms in the manner I talked about, we expect the carbon emissions of the whole site, the operational carbon emissions, to drop by 25% and 15%. We didn't assess it at the community centre, but if we roll out widespread replacement of all the heat emitters, up to a 44% reduction of the heat pump, that's only 20% of the overall boiler capacity. The interesting thing is, because the heat decarbonisation plans are basically costed feasibility studies, we've worked with a QS. We do a fairly robust costing exercise, and we come up with a £1 per tonne figure. And of all the measures that we've looked at, and this is consistent across many, many heat decarb plans that we've done, the heat pump in a lead heat source capacity generally comes out at the lowest number in terms of pound per tonne of carbon saved. So it's a really cost-effective way of making a big impact. Now, this isn't a silver bullet. This doesn't give you a net zero carbon heating system or building, but it does make a massive difference. It could be a first step for people. It could form part of a modular approach, and it will have to form part of a modular approach. But it's a real game changer, we think, because we've seen huge appetite from the market. As soon as I have this conversation, people can see a way forward, basically. And we've seen that just in terms of the feedback that we get and the conversion rate of the bids that we're putting out there to do these studies and to do the implementation. And quotes that have been made from various public sector bodies or higher education facilities, like, this is a pragmatic approach, you know, it gives us a viable step way forward. It's a real world solution. There's some pretty, an Energy and Carbon Manager at a local authority made quite a statement when he said to me, this is the predicament we're in. You know, if you want me to decarbonise that building, which care home would you like me to close? They simply don't have the money, you know, so that's where they are. So if we review all of that against the big picture, we know that every building needs to be zero carbon by 2050. And most organisations have aspirations or commitments to be well ahead of that requirement, most around 2030. There's other drivers, such as the minimum energy efficiency standards, which I think are massively under the radar, which have got some quite onerous mandatory requirements. You're going to have your EPC ratings to be by 2030 on anything that you're letting. I just don't think the market has truly processed that yet. Most people are unaware of it when I have the conversation. And there was quite an interesting statistic that Salix have just released their Low Carbon Skills Fund Phase 4 to commission more heat decarbonisation plans or designs. There's a statistic in there saying that basically of the 30 million buildings in the UK, basically equate to 22, the heating systems alone equate to 22% of the UK's entire operational carbon, scope 1 carbon emissions. So you can see the scale of impact that this could have. Now, my personal take on this, I think through the conversations I've had with estates directors, higher education facilities, FM teams, this is the analogy. People are like rabbits in the headlights. State that the scale of the challenge is so daunting, they just do not know where to start. And because of that, it's leading to inaction. Nobody's doing anything because they just don't know where to start. So my closing question, I think, is, in reality, do we really have time to wait for the opportunity to present itself for fabric first all electric solution rollout? I think the answer is probably no. Thank you.
So much, some really important insights there about the challenge, and also great to see that there is this appetite in the market. We have time for one question for the team. Would you like to ask something? Valentina, sorry.
A quick one. So I thank you for the presentation, brilliant. I'm wondering what are the operational energy costs of the different scenarios that you that you showed in the slide?
I think there's a misconception in the market that decarbonising results in OPEX savings. And I would say on most schemes that we look at, that opportunity is limited, probably at best. You're probably looking around about cost neutral. But for the leisure centres, we said that, you know, in the 6 months or so that we've had 3 of them open, we've saved 100,000 quid. And I think the reason there, particularly with the leisure centres, is because all the loads in the pool hall, we can use the 45-degree flow temperature to do the air load in its entirety, to do the pool load in its entirety. So I think, yeah, that there is opportunity to potentially save money, but my advice to anybody when I'm having the conversation is don't expect it to save you money. So.
Is there any time?
If that's okay, we can continue during. So we're running a bit late, but we're still. We'll aim to go